Hi. So, for experiment 1, heat exchanger, there are two main objectives. Objective number 1 is to compare PID1 and PID2 control systems, where PID1 has a lower D value compared to PID2. And the response of each of these control systems is recorded and observed in terms of which control system produces less time to reach its set point, and to also see the presence of oscillation and also overshoot. So now objective number 2 is to compare P, PI and PID1 control systems and see the response of these control systems in terms of their settling time, presence of overshoot and oscillation, and to also see which of these control systems are the most suited for this process. Thank you.
Now, let's move on to the working principle of this experiment. Firstly, this experiment aims to control the heating of cold water using a shell and tube heat exchanger. In the system, the process variable is the temperature of cold water, which is measured using a thermocouple. The set variable would be manually inputted by the user, and the manipulated variable would be the valve opening, which will directly control the amount of hot water supplied to the heat exchanger. The tunings of the controller were varied to toggle between P, PI, PID1 and PID2 controllers. For each of these controllers, the system was allowed to stabilize at 30 degrees Celsius before introducing a step change to a new set point of 45 degrees Celsius. Then, the system was allowed to stabilize, and the time taken for the system to stabilize and the final temperature were recorded. The behavior of each controller were summarized in the response graph produced.
So hi guys, I'm Prakash, and right now I'll be explaining on the startup procedure of this heat exchanger module. So let me run you through the processes and first of all the hand valves. So as you can notice from here this tank is the cold water tank, and make sure this pump is open so that we can supply it to the pump here. So it flows through this rotameter all the way through here and to our shell side of our heat exchanger, and that exits over here. This is the exit, and it moves, so make sure this hand valve is open. It will move into this intermediary product tank. Alright, so at this point the intermediary product tank, we won't be using this pump because this supplies it directly to the radiator above. Alright, so in this process we won't be using this. And I'll touch on that later on. Now moving on, we'll have the next one, which is the hot water tank. So the flow from here goes under here, which goes through this pump. So make sure this valve is on, and it goes up through this flow meter over here and goes into the tube side of the heat exchanger, and it comes out over here at the bottom. Alright, as you can see, it goes through the bottom, and as it goes along, you could see it coming up to this control valve. So make sure these two valves are open and the bypass valve is closed, and the rest of the water flows back into the tank.
As for the general shutdown procedure, first we off the pump. This one is the hot water pump and the cold water pump. And then we turn the panel to DCS. And then we close the valve of the air regulator. Lastly, we switch off the main power. Thank you, that's all.